Welcome back. In this session, we will talk about data store consideration. Let's take a typical database. A typical database has set of rows and columns, and this forms a table. A table can have a schema which defines what kind of data you're going to put. It will have a primary key upon which search can be made, insertions can be made, and it supports indexing which enhances your queries. That could be bunch of data tables, and this whole setup is called a database. The database which we just described is a SQL database or a RDBMS system. This is best suited for situations where your data is normalized. RDBMS guarantees high integrity and data consistency. What this means is the data is consistent across transactions. It doesn't get corrupted. Data conforms to a specific schema. This also means you can use it only in scenarios where you know the type of data which you are going to put into. The size of the data in an RDBMS system is typically low to medium. Examples of RDBMS database are where you want to store reporting data, accounting data, or a fund management data. Okay, we have a SQL database. It works well. Do we need anything else? Are there other type of databases which required? Before we go into that, let's look at how does modern applications work. Modern applications have varied data needs. What do I mean by that? The data comes from different sources. It could be from your mobile, it could be from your system, it could be from a PC, it could be from a car, it could be from an IoT device, it could be human generated traffic like a chat, like a tweet. The data predominantly is heterogeneous in nature, so there is no conformed schema, there is no specific format, it can come from different places. And the volume of data is huge. So, is there an alternate to SQL database which can cater to these kind of data needs? That's where the NoSQL databases come. What do you mean by NoSQL? NoSQL is not only SQL. These are by default distributed. They are designed for scaling horizontally. In contrast, the RDBMS database usually scale vertically. So you will have to put them in a powerful machine with more CPU, more RAM, and keep scaling them vertically. NoSQL databases are designed to scale horizontally. They are schema free, so they can adapt to any kind of data which is changing, and they don't really enforce what type of data you can put in. NoSQL databases often thrive for eventual consistency, which means in between the database could be in a stale state, but eventually the data is consistent across all systems. Let's look at different type of NoSQL databases. The first one is a key value store. Here, the data is stored as a collection of key and value. The data is queried predominantly based on the key. You can think of this as a hash or a dictionary. These are massively scalable systems. The data usually tends to be very large, and some of the examples are data caching, session management, user preferences, and profile management. Usually, key value stores are optimized to store different type of values which are heterogeneous in nature. As in the illustration, you can see the first key stores a bunch of string, the fourth key stores string, number, and date, and so forth. So the value which is stored is usually opaque to the system. The search happens only based on the key. You cannot search a key value store typically based on a value. The next NoSQL database which I would like to talk about is a document database. A document is a collection of field and data. A data here can contain list or even child collections. As seen in the illustration, the document 3 contains a field called full name which has a child collection within it. This document database also usually stores the whole data as a single entity. This is in contrast with the RDBMS system where a data for a particular entity may be split across different tables. The document database allows indexing based on different values. So you could have indexing based on different fields. The document database also ensures that there is no schema so that the fields are optional as shown in the illustration. The document 1 has name, document 2 has full name, document 3 has full name, but there the name is split into first and last name. So this is really a powerful way to store heterogeneous data. The queries in a document database can involve values as well. So you could ask a document database to give you all the documents with the first name being Adam. Some of the examples where document databases can be used are storing product catalog information or user account information. The next type of NoSQL database which we would look at is a graph database. Graph database is a collection of node and relationship. Here, node may be a document, like we just saw. In addition to the document, what a graph database stores is a relationship. Relationship is treated as a first-class citizen. Relationships can change dynamically and frequently, and that the graph database allows you to do that. Relationships can have a property like direction or a type. Let's take example of the illustration which is shown here. You see in blue an actor Tom Hanks, and the green circles around it are the movies he has been involved in. The arrow mark is the relationship which says has he acted in it or has he directed it. This gives the benefit of NoSQL of being schema free, having being able to dynamically change values along with storing the information. Examples of where graph database can be used are organization charts and social graphs. To give you an intuition, you can think of graph database in comparison to RDBMS and other NoSQL like this. If you have data which are very distinct and they do not connect each other, there is no relationship defined, you use any of the other NoSQL data. Relationship databases, relational databases give you certain amount of relationship between the data. But if your data is primarily focused on relationships, if your query has to be based on relationship, track down, to give an example, let's say there's an organization chart and you want to see, give me the list of people who either report to or who this entity reports to. So you want both the reportees and the supervisor of a particular entity. So such queries are easily made in a graph database. So the in graph database, the focus is on relationships. The next NoSQL database which I would like to talk about is a wide column store. Here, the data is organized in a row and column, much similar to RDBMS. So it may, at a concept level, this may seem very similar to RDBMS. But the distinction is, here the columns are logically divided into column families. The column families are often retrieved and manipulated as a unit. Let's take an example. Let's say you are storing information about employees. So you can have a lot of data related to employees, which become the column. Now you group the column into different column families. One example could be you have a user profile which has the email ID, the phone number, probably the employee ID. This becomes one column family. You can have another column family for the same employee which talks about the projects they have worked on, the technologies they have worked on. You can have another column family for their extracurricular activities, their hobbies, their interest, and so forth. The main difference is when you get into a column family, it will have different rows, and each of the row can contain different columns. So some may have a particular column, some may not have a particular column. In this particular case, in the example, you will see Bob has email address, gender, age. Brittany has only email address and gender, whereas Tori has email address, country, and hair color. So the column is not enforced in every row. Columns can be easily added as you want to change the data format without having to redo the whole database. Queries are optimized to retrieve just a particular column family or data within a column family or even across column families. That brings us to the end of this session. What did we learn in this? We learned difference between SQL databases and NoSQL databases. We also learned the different types of NoSQL databases, namely the key value store, document database, graph database, and the white column store. We also saw when does it make sense to use one over another. That's all for now. As always, keep thinking cloud and get back to us if you have any suggestions. Thank you.